And again, welcome to the webcast today, Understanding Database Options on AWS. Our presenter is Miles Ward, Senior Solution Architect at AWS. Miles, you have the floor.
Oh, and thank you for the introduction, and welcome everybody this morning to our presentation. I appreciate you taking the time. I've worked for quite a while with several different customers across several different industry verticals, and it doesn't really matter which kind of applications businesses are looking at deploying. Almost all of them depend in one way or another on database technology. What I'll present today is an overview of the really broad set of database options that are available on AWS, the best practices and general overviews for the right kinds of tools to use from us, both from what we'll call an unmanaged or a directly installed pattern on Elastic Compute Cloud or EC2, as well as more managed services from Relational Database Service, DynamoDB, Redshift, and others. So to give a quick sort of first view, recognize there are a truly startling number of options. This is a simple subset, but there are literally hundreds of different ways and types of database software that are running today in production for hundreds of customers on the AWS system. So to kind of go left to right on this view, I think probably the simplest and typically having the most in common for the way that you would deploy databases, maybe in an existing data center or in your office or your own facilities, would be to install relational database software on EC2 or the Elastic Compute Cloud. So EC2 supports installation of any really Windows or Linux x86-based database software, so Oracle or SQL Server or MySQL or DB2. There are literally hundreds of options at this tier. We've heard from customers that process, the steps to installing databases, the work of managing those databases is complicated and time-consuming, and so we've offered databases as a service. We have three of those: MySQL, SQL Server, and Oracle Database Server 11G and 12C are available on AWS. Just like there are relational database services that handle transactional data, online transaction processing, the ability to handle relational interconnections like joins and unions inside of your data set, there's a new model for development and implementation against structured data that doesn't depend on the SQL query paradigm. So that idea is called NoSQL. We have a whole litany of NoSQL database options that can be installed on EC2. Again, maybe similar to the way that you might install NoSQL database software in a data center or in your own environment. That means that you download the software and install it locally. You get it set up to run on an EC2 instance, potentially distribute that software across multiple instances. And we support things like Mongo and Riak and Couchbase and Cassandra. There are, again, hundreds of those options as well. We've heard from customers in the same way that the complexity of implementation and setup and management for NoSQL databases is the same as the complexity associated with the setup for relational databases. So we've also built some Amazon-managed services for NoSQL. SimpleDB and DynamoDB are two examples there. We've also heard from customers that some of the newest topology styles where data stored entirely in memory is a model that provides a kind of performance acceleration for systems that's very different than either the NoSQL or the relational database model. So Memcached is kind of the first of the entrants into that system. You can certainly run Memcached on EC2 or use commercial products like HANA from SAP or a managed service from Amazon like Elasticache, which is a Memcached managed cluster on AWS. A third really a fourth whole category of structured data services or database services on AWS is data warehouses, applications focused on the OLAP, online application processing, and analytical processing workloads. So in the same pattern, there are the ability to directly install data warehouse software like Vertica or Teradata or Hive or HBase, these other systems. That's something that's available to install on EC2. And similarly, we've heard from customers that that's complicated, and so we've built managed services like Amazon's Redshift system or Hive and HBase on Elastic MapReduce that provide a more managed experience. So to kind of summarize that really rapid overview of what it is that we have, there are database services on AWS, a subset of which we would characterize as managed services on AWS. So we'll go through in greater detail each of these different options, help you understand the value propositions associated with the managed options, what kinds of values they add, the things they make easier, the complexity that they remove, and then also if there are any the places where implementation limits or upper maximums for scale or other kinds of constraints may drive you to one or the other kind of implementation. So to jump in right at the top of the list, starting with SQL or relational database deployment options on EC2, probably the first example that makes sense is Oracle database. We have customers that are running not only dev and test workloads, but full production environments. Oracle has evaluated and allows the Oracle 11G database running on top of Oracle Enterprise Linux for full production software support. One of the big advantages to being able to run an Oracle database in this way is that, like any application that runs on EC2, you're able to take advantage of that hourly pricing. So if you need to run, say, a short-term, very large Oracle database to be able to run an analytical process at the end of the month for end-of-month reporting, you could just turn that on the last couple of days of the month, run it 24/7 those 2 days, and you pay 1/15 of what you would pay if you ran that big machine all month long. We've pre-built Amazon machine images, so getting started with Oracle is very, very easy. And you can use not only our licenses for Oracle, where you pre-buy with us, or you can port existing licenses that you already own onto AWS. AWS is the first supported Oracle certified cloud platform. They've been able to certify us because we've been able to launch the complete Oracle stack. So when you launch an Oracle Amazon machine image on AWS, we'll actually deliver that image on top of what's called OVM, the Oracle Virtual Machine Image, their own certified virtual machine stack. So that ensures that your Oracle systems that run on AWS receive end-to-end support from Oracle. This process is maybe a lot easier than you'd expect. You can really get started in about 4 steps. We already have pre-built Amazon machine images that you can find through the management console. So even if you've never used AWS before, and the first thing you're going to do with us is try out an Oracle database, the steps are create an account, log into our web console, find one of the AMIs through the EC2 management console component where you search for AMIs, and launch an instance of that AMI. Once the instance is up and running, again, that usually takes between 5 and 10 minutes, you'd be able to right-click on the running instance and select Connect to Instance, and that would give you a dialog for SSH access to the Oracle database server. So pretty straightforward, something we're seeing even new customers able to do inside of their lunch break, not something that should present a big impediment to even the highest scale deployment. So in terms of the next option, the next kind of major relational database service Microsoft SQL Server fits effectively the same pattern. We work together with Microsoft to build SQL Server Amazon machine images, and we offer SQL Server software. That's SQL Server Express, which is free, Web, which has a relatively low per hourly price for databases that back websites and web applications, and SQL Server Standard for full application workloads. Each of those are available by the hour. So you start an EC2 instance that includes the SQL Server and Windows Server license costs as an integrated part of the price. So no need for you to bring your own license or do any of your own installation or setup. If you have your own existing SQL Server licenses, you can use those. You'd start a standard Windows EC2 instance and install your SQL software and go forward from there. Those pre-configured SQL Server instances offer that same benefit where if you need to run a database for a short period of time, you only have to run them for the period of time that you need them. You also can change the size of EC2 instances by rebooting databases. So you could go from all the way down at the bottom on an M1 small instance with 1.7 gigs of memory and restart that instance onto an M2 4XL with 68 gigs of memory. So really huge shift in scalability available pretty quickly through our management console. So those same deployment steps, creating a new account, looking for SQL Server AMIs, available now in SQL Server 2008 as well as SQL Server 2012, and launching those instances from our console gets you to a running instance. Windows takes slightly longer to boot due to the sysprep process, so in 10 or 15 minutes, you'd be able to use the remote desktop protocol to get to the same Windows desktop experience as you're used to for managing existing servers. So each of these relational database systems also depends on the storage system that you use. And each of the pre-built Amazon machine images attaches an EBS volume, an elastic block store disk, for delivering block storage to the database interface. For each of these Amazon machine images, you have the option during the management console launch wizard, or when you create this instance from our command line tools or via our API, to enumerate additional disk resources, both either standard EBS or provisioned IOPS EBS, higher performance storage system. So with provisioned IOPS, you'd be able to deliver EBS, single EBS volumes all the way up to 4,000 IOPS. And we very strongly recommend that relational database systems be deployed on top of provisioned IOPS, even if you intend to run them at relatively low IOPS rates, 100 IOPS, 200 IOPS, still a system that was designed to support the database environment. And we'll talk through more implementation tips that generally apply to all of these database options as we go along. So these are the relational database services that are pre-built in, and again, there are many more that we can cover. Certainly, folks run MySQL and Postgres and DB2 and several others. Certainly recommend taking a look at aws.amazon.com, where we list out the full set of Amazon machine images for database products or relational database products. But we've also built, and I want to make sure that we take the time to review, managed relational database or managed SQL deployment options on EC2. So for relational databases that are managed, we call that the Relational Database Service. So RDS is fully managed and allows you to deploy MySQL or Oracle or Microsoft SQL Server as a managed event. And what do I mean when I say that's a managed service? So we allow you to choose the database engine and app version that you want, but then beyond that, we provide managed automated backup, automated disaster recovery tools, significantly more detailed monitoring and instance replacement, direct management of storage configuration, and for some of the versions of the database engines, multiple AZ or multi-AZ deployment. We'll talk through what each of those different tools means. So again, rather than imagine with the SQL Server or the Oracle Server that we just explained, you install the software and then you remote connect to the database server and use the built-in tools to sort of observe that database or configure it. With Relational Database Service, you can stay within the Amazon Web Console and do all of the administrative work required to set up and configure and launch the instance in a known good state where we are the ones managing the back end of the database. So that means that you aren't able to remotely connect to the operating system that hosts that database. We create a subdivision where, because we're in charge of managing the database system, we'll keep that access control, and you configure your system by web services, by remote access. The advantage of that is what we heard from customers running large-scale databases is that a big chunk of the time that's spent managing or running a database system is very undifferentiated, sort of heavy lifting. You're constantly running backup processes. You're upgrading and patching and migrating to new versions. There's sort of constant license auditing, those other pieces. A lot of that work isn't any different from user to user, and but at the same time, it must be done. And so RDS automates those parts of the work and makes it so that you simply set up backup schedules. We allow point-in-time restores of your database, which are stored in S3 every 5 minutes. We have all of this sort of sophistication around management of the database so that you can focus your DBA's time on the higher value, higher benefit work of performance tuning at the index and query tier, at data modeling, and at scripting and integration above the database tier. So if you look at backup and recovery and durability, RDS has really built some sophisticated tools there. First, you can drive a snapshot of your database at any time. Say you're about to make a significant change in structure, you can back up the database on demand. We also take automated backups at any point. So we're doing that on a daily basis at a schedule that you set. We're also taking point-in-time restores, duplicates of the logs, every 5 minutes into the S3 environment. We really enable a very high durability and a very protected against logical failure kind of an environment. If you accidentally delete a bunch of data, being able to restore from a recent point-in-time snapshot is very powerful. Independent of the sort of manual work of restoring from a database failure or something like that, you also want to have high availability built into the design from the get-go. So RDS, in particular for the MySQL system, allows what's called multi-AZ deployment. So we'll just with another option that you picked at instance startup time, or with a change in the configuration in any running RDS database, we're able to deploy a fully synchronous, not asynchronous, a fully synchronous replica of your data into a separate availability zone. That's a different fault zone inside of AWS, so a totally separated facility. And that means that if there's a problem with the instance or the hard drive or the network connections or even the whole building, if a meteor strike takes out a whole availability zone, the other availability zone is very likely to still be online. So it can be a really powerful tool for delivering high availability if you're deployed in this multi-AZ mode. We won't even charge you full price for that secondary copy, and that enables an SLA on durability or an SLA on availability for the database service, which is pretty powerful for your design. So another component that we hear from customers all the time is they really are focused on the scalability of their databases. So multi-AZ uses synchronous replication that's used for HA. We also enable native MySQL asynchronous replication to allow you to stand up what are called read replicas, duplicates of the database that are kept asynchronously aligned with the primary database to serve downstream reads. This allows you to grow your database system to accommodate even up to 5 downstream read replicas, so 5 times potentially as much read traffic as the primary can handle. That also saves workload on the primary, unpredicted workload on the primary, because it can spend most of its time focused receiving writes. And that system can work together with multi-AZ, so there's no reason not to have a synchronous replica as well as asynchronous replicas for read scalability. So we've also listened to customers and heard from them, these capabilities. I want databases that I can grow whenever I want, or frankly shrink whenever I want. I want the ability to remain highly available, independent of whole data center failures, and I want to be able to scale when I need to scale, particularly on the read side. We really built Relational Database Service, RDS, to handle each of those pieces. We also know, and this is where Elasticache fits into the pattern, we know that Memcached, by buffering the answers to your database queries and not the inputs that are asked questions by your queries, by buffering all the answers, Elasticache can make web applications and other systems much, 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 much quicker, and can really increase the scale of read capacity for a given application. So that's why we built the Elasticache service that allows you to even further multiply the read capacity of your database environment. So it's another component of this, make sure as you're evaluating licensing between systems, Oracle RDS is one of the options and will allow Oracle licensing systems. You can use existing licenses from Oracle, or you can purchase new Oracle database licenses to use on Amazon, or you can use our integrated licensing. So recognize there are several different models there. Certainly important for any of the database software that you're going to use that you clearly understand the software licensing and take advantage of the pricing model or licensing system that fits best for your workload. So that's relational databases in a 15-minute whir. Certainly there's more data out there than that, but I think it makes a good overview for folks to understand both the unmanaged and the managed option for relational databases on EC2. So now looking at the next style of database systems, NoSQL systems, there are similarly lots of deployment options and choices for NoSQL systems on EC2. We've heard from customers that because each of these different systems use different terminology to describe themselves, because this is a market that's, frankly, much newer than the relational database market, which has, I think Oracle's been around for quite a while, and MySQL's been around for quite a while, and SQL Server's been around for quite a while. Several of these products have, are relatively new, backed by startups, have, smaller user bases, and represent kind of cutting-edge approaches to solving these problems. So we've worked together with 3 of them, with MongoDB, that's powered by a company called Tengen, with Riak, powered by a company called Basho, and with Couchbase, to capture their best practices for installation, implementation, backup, scalability, maintenance of their NoSQL systems. We've written white papers that will help folks digest the best and most efficient ways to deploy these NoSQL systems on top of AWS. So those 3 we have manuals for. It's not to say those are the only options. And this is one of the areas where there's really significant variability in the applications themselves. So be sure, as you look at the specific workload that you have, or the programming experience of your developers or your data analysts, to evaluate carefully a database or a NoSQL database that best fits your need. They offer very different value propositions. There are even some that tread this line between NoSQL and relational or SQL databases some of them called new SQL databases like NeoDB or Clustrix that are also potentially worth evaluation. So one of the most important things we've seen in the NoSQL environment may be different than relational database environments, where in relational database systems, there's certainly very heavy CPU and memory constraints on performance. Many NoSQL systems have somewhat lower requirements for CPU usage, and as on the other side are very, very bound by storage performance. So I want to spend a quick couple of minutes talking through the storage system options that exist behind really SQL and NoSQL data systems. So if you look at your several different relational databases as well as NoSQL systems, will use some small block random operation to handle the individual writes to and from storage. So standard EBS, we did a set of testing using MongoDB as one representative application. Mongo uses 4K reads. SQL Server from Microsoft uses 8K reads, and Oracle is configurable for 2 or 4 or 8 or larger K reads, and MySQL defaults to 16K reads. So it's important to keep track of what the correct block size is for your database application. But in this case, using 4K reads, using a single EBS volume, we were able to extract on the order of 200 or so Mongo operations per second. That's at the high end of what I would call sort of steady state performance of EBS at more like 125 to 100 IOPS. If you took an EC2 instance and attached a bunch of EBS volumes to it, you could probably get into the 1,000 IOPS range, again at the sort of 10 megabyte a second or so throughput to storage. Provisioned IOPS offers much higher performance density, up to 4,000 operations, or about 4,000 IOPS to storage, again with significantly lower variability, sub 1% variability. So a single volume in this case is easily 6 times, if not significantly faster than that, compared to a standard EBS volume. And if you were to connect multiple EBS volumes to the EC2 instance that hosts your database, you could go all the way to saturating the network link that exists between EC2 and EBS. You can optimize that link using a flag called EBS optimized on an M2 4XL or a C1 extra large or an M3 2 extra large. That would be a gigabit of throughput or about 120 megabytes a second as shown here. The third option for these that's becoming popular is our EC2 instances that have solid-state disks locally as their ephemeral storage. So it's very important that you have a duplicate of that data. Ephemeral volumes can be lost at any time if there's some kind of a problem with the instance, but the IOPS performance and the throughput is nothing to shake a stick at, certainly very, very high performance. One of the important measures to note is the difference between the very fastest systems on AWS, the SSD hosts from high 1.4XLs, but provisioned IOPS as a system was designed for extremely consistent performance. So if you look at a single EBS volume, you can see pretty significant variability in the per second IOPS performance. On provisioned IOPS, you're seeing less than 1% variability. In many cases, it's only 0.1% variability on individual writes per second to storage. And the SSD hosts, while they're certainly able to deliver tens of thousands of IOPS to storage, they still exhibit higher variability in that you're interacting not with a managed storage service, but with the physical devices themselves. So important as you design your database system that you evaluate the right options for storage and that you incorporate that decision-making into your design. It's probably one of the earliest and first sets of decisions you should make. And we found for most customers that that decision is complicated, that there's risk involved with making that choice incorrectly, and that it can be difficult to stand up what many of these systems recommend, which is multi-node clusters distributed clusters of EC2 instances for deploying the NoSQL database. And as a result, Amazon has built a set of managed NoSQL services. So the first of those is a service called SimpleDB. SimpleDB is a unique system, relatively one of the first Amazon Web Services, designed to make the kinds of applications where you just need a couple of rows of state data stored and accessible and useful as a way to get that data back and forth from your application. So SimpleDB is accessible over REST. It doesn't expose a SQL query string or an ODBC or JDBC connection set. It's not designed to host your OLAP cubes or do any of maybe the more standard things that a relational database would do. What SimpleDB does instead is provide a zero management, zero overhead, zero configuration, zero administration service for delivering the kinds of back-end data that game applications and we have a lot of services that are built for administering even EC2 as a metadata storage service. You can use it as the index store for your S3 buckets. It's a great place for small application designers who don't want to deal with the work of setting up a database to be able to have that service without any of the headache. So we heard with SimpleDB, one of the first places from customers that they wanted to get more features from AWS was that SimpleDB has an upper maximum of 10 gigabytes per SimpleDB table or SimpleDB data set. And 10 gigs is plenty if you're going to store data for a small application or an infrequently changing data type or something like that. But if you have a huge amount of data, or if you need the transactions to happen much more rapidly, SimpleDB is designed for double-digit millisecond inserts and retrievals of data. DynamoDB is a new option from AWS that provides a managed NoSQL database. This may sound familiar, a little similar to SimpleDB, but it's designed to be extremely fast and designed to have unlimited potential storage and throughput capacity. So you tell us how fast you want DynamoDB to go, and that's how fast we'll make it go. You actually literally tell us, I want 160,000 IOPS on my DynamoDB table. We will configure it for 160,000 IOPS. Those transactions are metered both on the read and the write side. So you can build a database that's designed to accommodate huge bursts of reads and you only write a small number of changes at a time, or the opposite, if you're capturing logs of data from remote systems, it can support huge balloons of writes. And you configure that literally by turning up and down the performance for read and write at the table tier. And so that's really different than figuring out which kinds of hard drives and how many instances and what kind of network setup and what kind of tunables at the operating system. You don't have to deal with any of that stuff. You just tell us how fast you want it to go, and we will make it that fast at whatever scale that you need. That service is built on solid-state storage, so it's designed around and built to take advantage of that storage topology. And it really allows you to build in a way that reduces risk in these sorts of NoSQL systems. So one of the core ideas behind the NoSQL model is looking at partition tolerance as a component of the CAP theorem as a benefit and a focus of the design of the system, potentially at the expense of consistency. So DynamoDB has a system that allows entirely consistent writes and your ability to optionally elect for either eventually consistent or consistent reads. So you pay us, it's a double, it costs you 2 IOPS basically, or 2 operations, two read operations per second to do a consistent read versus 1 read operation to do an eventually consistent read. But again, you just change the number, and now you're able to do consistent reads in a NoSQL data system that is distributed across multiple availability zones within your region. This is an entirely storage-based system, so it's not an in-memory system. If we lose power, we don't lose data. And it's designed as a regional service, continuously replicated again across these multiple availability zones for high availability. So lots of different use cases make sense for DynamoDB. If you're looking at NoSQL databases at all, Dynamo is at least worth a view. And that consistent reading and writing structure is a commitment that's pretty difficult for your average NoSQL system to meet. So it's important to eyeball that. A constraint that exists today is it's important that your item sizes remain relatively small. So it's important that you can certainly keep any size data that you need in AWS. You could store a 5 terabyte object in S3 and store the pointer to it in DynamoDB, a URL to that S3 object. But very, very large objects inside of this database don't make a lot of sense, and 2, aren't particularly efficient to store. An individual row won't tolerate that higher data size. So if you're looking at sort of making the choice between SimpleDB and DynamoDB, an important part of this is, SimpleDB offers automatic indexing across every column in the data set. So if you have a really widely varying range of data that sits all in the same table, you can expect SimpleDB to make a best effort at optimizing those tables and giving you good query performance independent of which data element you choose to query on. DynamoDB offers a somewhat more structured and more enumerated process for indexing. It offers what's called a hash, the original ID of the item. So you can think of that as typically the leftmost column, and then the range, which is maybe the data value that you'd want to sub-select on. So, give me all of the IDs within the last 24-hour period, or give me all of the IDs that have their integer values set greater than 1 billion, something along those lines. DynamoDB also supports secondary local indexes, so you can elect to have additional tables that are indexed for the purposes of querying, and that consumes write capacity and read capacity units as well to support that query model. So a little more upfront planning on the DynamoDB side results in a higher scalability, higher performance system in the long term if you have that kind of predictable view. So we also have some customers that kind of get started with SimpleDB to learn the real patterns inside of their query model and then migrate data to Dynamo as they have a clearer view at their index model. So another tool we talked about a little bit in the relational database side, Elasticache offers this pre-configured, pre-deployable memcached caching environment. One of the reasons that it also fits here in this NoSQL model is there are lots of application development libraries that are starting to use Elasticache as a session data store, as a temporary data store for interchanging data between applications. It can be a good place to put data that you want to store in memory rather than commit to a storage device like with DynamoDB or SimpleDB. So we've also seen folks using Elasticache in particular to pretty radically increase the performance for applications that are read heavy. So again, imagine, if the query that you've written says, in a relational database, give me the count of the number of users whose name is Miles Ward and whose job title is Solutions Architect, and your user database has every person alive on the planet, some 7-odd billion people, it might take a while for your relational database to scan through the whole table to find the answer. But if your application asks the question, how many people named Miles Ward are in the database, and it asks that 100 times a minute, if you just store the answer, there's only one Miles Ward who's a solutions architect for Amazon Web Services. The count is 1. You store the 1 instead of a compressed summary of that billion-row table or anything else. Serving up the 1 as an answer is going to be dramatically faster. So an important part of full-stack application design. So beyond NoSQL and relational databases as the sort of two primary paradigms for application interaction and user interaction models and logins, logouts, all these other kinds of operations, the far other end of the spectrum, the analytical processing, the OLAP workloads, is a very powerful use case for cloud because we have the scale that allows you to analyze these petabyte data sets. So deploying data warehouse software that's optimized around just the analytical processing side of the workload, not the transaction processing side, is pretty popular. There's a service called the AWS Marketplace, and you'll see several links on this page to different data warehouse systems that are built on top of the warehouse, on top of the AWS Marketplace. That allows you to quick deploy, like for example, ScaleArc or Treasure Data or Extreme Data or BitYoda on top of AWS, pre-configured, pre-managed, ready to run. You don't have to do any sort of installation. You get to follow their process for logins and making sure that you get access to database software. There's also great how-to manuals on running Vertica and Teradata Express on EC2 that those companies maintain. Again, those are really straightforward processes for getting those softwares downloaded and installed and configured. Similar to the discussion earlier around storage options, it can be pretty critical to ensure that the storage is configured properly for data warehouses. Depending on the query model, assuming a more sequential data access pattern, standard EBS may offer at a price to performance ratio a higher throughput to storage than provisioned IOS was designed to offer. On the other side, if you need very consistent access to storage, provisioned IOS is always the first choice there. So data warehouse software, another component that's going to be important because in many cases you're putting very critical, secure customer data into the warehousing environment to do analytical processing. You want to make sure that your security design for these kinds of systems is well built. So not only does that mean encryption in rest and in transit, you should be connecting to these data sources using SSL, and there should be some kind of encryption at the storage tier. You also want to make sure that your backups are encrypted. And for access to these systems through the AWS console, you'll want to use identity and access management to control and limit your users potentially to only accessing the tools from AWS that they need and carefully controlling things like SSH keys or RDP passwords to ensure that access to the individual servers is well managed. We also offer a service for identity and access management and AWS called a multi-factor authentication token that makes it easier to have a two-factor authentication when you log in. So all important tools. We heard from customers that getting this kind of warehouse up and running, particularly one at scale, was potentially complicated. And so AWS has built a managed cloud data warehouse called Redshift. We designed this data warehouse with a real focus on making sure that things were faster and cheaper and easier than your standard sort of data warehouse implementation. We've done that by building a lot of new technology, frankly. We really wanted to focus on the enterprise core data warehouse, the big data challenge inside of these newest businesses and the oldest businesses that are built on ancient data warehouse systems to get very, very high performance access to all of their data. So we worked with like Airbnb. They're at a quarter of the cost and sometimes 20 times the performance in comparison to their Hive environment. We worked with Accordant. They were able to cut down by 40x the query time. We worked with Nokia. They were able to cut their cost in half and double performance. So very high performance, very low cost system for data warehousing. And it's able to provide those benefits because like many of the scale-out MPP columnar storage systems for data warehousing, Redshift compresses and optimizes data around the storage topology to ensure that you're able to deliver queries at an incredible high speed, even though you've actually reduced the random I/O to storage. So another part of the data warehouse topology that's pretty convenient as a part of the Redshift cluster, we know that most systems are dependent in clustered MPP architectures on high-performance networking as well as high-performance storage. So we've built on top of our cluster compute network. That's 10 gig full bisection, non-blocking, zero oversubscription Ethernet. And in the Redshift architecture, we deploy and manage the leader node in that cluster. So you only pay for the working compute nodes that are a part of your warehouse cluster. So that cluster allows you to interact using standard JDBC, ODBC tool sets. We'll talk through external tools that work great with us. And then is natively backing up and ingesting data and restoring data to and from S3 as its external storage location. So when you create a Redshift cluster, you can grow and shrink that cluster based on your actual workloads. We offer a smaller node set called an HS1X large that has 2 terabytes of triple replicated data per node in the cluster. You can have up to 32 of those nodes. Or if you know you're going big, you can start with HS1-8X larges. Those instances have 16 terabytes of data per node, triple replicated. And you can have up to 100 of those nodes in a cluster. That means 1.6 petabytes of data in your warehouse, which we think is ready to go for even the biggest warehousing applications we've encountered. Each of those nodes has 128 gigs of memory, so that 100-node cluster offers terabytes of RAM for your application workload, all of which you can monitor directly through the management console. You don't need to use externalized tools. You can come straight to AWS to look at that stuff. And it also allows you to observe, optimize the queries that you use, explore those queries, and resize the cluster to take advantage of higher performance by having additional nodes as you get more data into the work system. We've also heard with lots of customers that they have external data integration services, ETL services, that you need consultancy to make sure that you're using your warehouse correctly. We've really built a full end-to-end pattern with Redshift to make it easy for customers to use and easy for customers to get help with. And then we've also integrated with several of the different business intelligence tools, JasperSoft, Burst, MicroStrategy, Pentaho, Tableau. Many of these connect using the standard PostgreSQL JDBC and ODBC connectors to allow all the good charts and graphs. In fact, we found for most customers that's a lot easier if they're able to deploy those BI stacks on EC2. So we've got several of those partners available through the AWS Marketplace. That means you can point and click and launch a JasperSoft or a MicroStrategy or an Attunity environment and then hook that up to your Redshift data warehouse. Pretty powerful. Another sort of note that really applies across all these different services. In many cases, one of the blockers we hear from customers is all this stuff sounds awful great, but how do I get my data up there? How do I connect to my existing environments? We've built several different networking and data movement services. So Direct Connect allows you to run private, non-internet, 1 gigabit or 10 gigabit or multiple 10 gigabit linkages from your data center directly to AWS, so that's not on the internet. Allows very low latency, high performance connectivity to the AWS fleet. We've also built virtual private cloud that allows you to connect over dual IPsec, BGP, high security tunnels back to your current data center environment over the internet, but over an encrypted channel. And then if you have terabytes and terabytes of data to move back and forth and your local environment doesn't have quite the network performance for that, we have the import-export service where you can literally mail us disks and we'll load that data into AWS. So if you look at across each of these different categories of options, you'll hear from Amazon that we have a service offering that meets the needs of thousands, tens of thousands, hundreds of thousands of customers today. We're really proud of not only the faculty but the diversity of these services, because we know that everybody's applications are different and we want to make sure that you have all of the choices available to make sure you make a good choice as you implement database services. We've got a bunch of questions in the Q&A panel, and I'm excited to jump into those. We have a couple of additional links here just to the products that we talked about today, but I'm going to take a minute to do some prioritizing here and then start answering questions.
Thank you, Miles. Before I head it back to go over questions, I'd like to remind everyone to please take a second to fill out our survey. The feedback that you provide helps us to improve our webcast, so we do appreciate your feedback. Just click on the survey button there at the bottom of the browser and it will open up in a new browser window. Please do this before we close out the webcast so you have a chance to fill it out. And with that, I will hand it back to Miles to answer these questions.
Perfect. So there's a good question. Virtual private cloud is a network environment that really represents the sort of go-forward future path for all production applications on AWS. It's really the place that you should be running. And so there's a good question here that asks, can RDS be a part of VPC? Can I run Amazon's RDS service inside of VPC? The answer to that is absolutely yes. RDS supports VPC totally, no problems with deployment inside of there. There's a question here around, is there a size limit on the SQL Server database for RDS or otherwise? So it's a great question. We've recently increased the size limit for the relational database service for all three of the database engines. We'll allow you to configure storage up to 3 terabytes and up to 30,000 IOPS of read-write performance. Now, each database engine, based on the way that it manages storage, will actually deliver a different number of real IOPS in terms of performance. So if the question here is SQL Server, we're seeing for most customers, even when provisioned at 30,000, real transactional performance is more at the 12,000 IOP range. That extra performance provisioning is more to do with providing adequate headroom for the application. But 3 terabytes is the upper size max today. So another question, is there an ability to replicate an on-site Oracle RDS database, an on-site Oracle database to an Amazon RDS instance of Oracle? So replication is available in lots of different flavors using several different technologies. So Oracle has not only native replication systems, but they also have internal secondary tools like Oracle's Golden Gate to create replication streams between applications. Today, because you can't log in to install anything else on the database server for RDS, the replication options are limited to the tools that work over the Oracle database connection string without on-instance or on-device services. So make sure that any of the models, that typically things like log shipping or other kinds of query-based synchronization, those all work just fine. So there's a question here about a loaded instance. We talked a little earlier around around an instance that has lots of EBS volumes as a sort of maximum performance throughput for each workload. And I'll spend a minute on this because it's an important concept. So if you have 1,000 megabits per second of throughput to and from an EBS optimized EC2 instance and EBS, you can chop that 1,000 megabits up quite a few different ways. Let's say that's 120 megabytes of throughput. If you're doing 16K operations or 8K or 4K operations, you can run a relatively high number of IOPS through that 120 megabyte channel. If they're 4K, say that's on the order of 40,000 or 38,000 or something along those lines. As you go to larger operations, you can run a smaller number of them through the same channel. So all the way the other direction, at 120 megabytes, if you are on really large blocks, 256K operations or some of these other operations that are popular with data warehouses, or file system operations that's a megabyte size, that's only 120 operations a second if you're doing a 1 megabyte operation. So it's important that you establish a disk subsystem and pick the right storage so that you don't either under-provision or over-provision against the actual storage workload and the network throughput to and from your compute instances. So in this example, a 4K loaded instance, yes, is an 8-disk RAID 0. MongoDB, in this specific case, will also do the same read performance on an 8-disk RAID 10 because it's optimized around reading from the RAID 10 pattern style. Each different database has its own best practices in terms of specific disk configurations that, again, are bounded by those throughput capacities. So another question is, there's a marking here that says, on that storage performance slide, we talked about low variability and less than 1% variability. Which one is lower? EBS, standard EBS, is a more variable service than provisioned IOPS EBS. So in this case, low variability was higher than less than 1% variability. There's another question here about setting up SQL Server clusters through Amazon Machine Images. So SQL Server clustering requires the use of Windows clustering, and we have a full, detailed white paper that explains every one of the steps required to build a functioning Windows cluster and, as a result, a SQL cluster. We even have CloudFormation scripts that allow you to pre-deploy all the different instances and to configure VPC in such a way that that cluster will work. That's a full, always-on SQL Server cluster. That requires that you deploy this on EC2. That's not a feature of RDS, but that's available on the AWS website. Just search for SQL cluster, and you'll see that instruction manual come up. We're almost out of time, and I really appreciate everybody's questions. Thanks for participating, and if there's any outstanding questions, we'll jump on those after we're done with the webinar. Thanks, everybody, for taking the time today.